When you are taking the union of those two, initially you have two relations, two tables f and g. If you want to take the union of those two, then they should be compatible for applying union. That means here we have four attributes a, b and c, a, b, c and d for this table, and this table also having the same a, b, c and d. So when you are taking this f union g, what will happen? Initially you are taking alpha alpha 17. That means you are taking all the tuples of this and all the tuples of this. That means here four tuples are there: alpha alpha 17, alpha beta 5 7, beta beta 12 3, beta beta 23 10, alpha alpha 14, alpha alpha 14, alpha alpha 17, beta beta 12 5, beta 12 5, beta beta 23 10, beta beta 23 10. Okay, that means when you have taken the union of these two, that means all the elements of f and g has to be combined, and that is f union g. Then duplicates has to be avoided. Here beta beta 12 3 and beta beta 23 10 and beta beta 23 10. That means that is a duplicate, so you have to eliminate that. And alpha alpha 17, alpha 17 and alpha 17, alpha 17. So this has to be avoided. That means now this is having 1 2 3 4 5 6. 6 elements are there, or 6 tuples are there for f union g. Okay, that's about union. Then suppose that if you are taking difference, f minus g. F minus g means all those which are present in A but not in B. That means f minus g means all the tuples which are present in F but not in G. That means from this relationship, if some tuples are repeating here, that has to be avoided. Be alpha 17, here also alpha 17 is, so in f minus g alpha 17 is not there. Alpha beta 5 7 is not here, so alpha beta 5 7 is there in the f minus g. What about beta beta 12 3? Beta beta 12 3 is not here. So again that is also qualified. Beta beta 1, beta beta 12 3. Then what about beta beta 23 10? Beta beta 23 10 is there. That means all the tuples are present here and not present here has to be avoided. That means the definition of f minus g is actually in as Venn diagram. This is like this. If this is f and this is g, what is f minus g? F minus g is this much. That means present in f but not in g. That means this is the result. Okay, that is all about f minus g. And what about f union g? F union g. F union g is not f union g, actually f intersection b. F intersection g. F intersection g means in f and g at the same time it should exist. That means present in both f and g. Here alpha 17 is here, alpha 17 is here. So alpha 17. Then what about alpha beta 5 7 is not here. Beta beta 23 is not here. Beta beta 23 10 is present here also. So beta beta 23 10. So this is f intersection g. F intersection G, then what about Cartesian product? So these are compatible for, that means if you want to take union, difference and intersection, if you have to take this, that should be compatible for, that means same structure should be there for both the relationships for union, difference and intersection. Now Cartesian product, as you know, suppose that our G is, say, I'm going to have a new relationship G. G is, say, going to have here E F, and now here it is A B C D. What will happen? If you take the cross product of F cross G, what will happen? This F cross G is having how many attributes? A, B, C, D, E, F. And first one is alpha alpha 17 AB, alpha alpha 17 CD. Then after that alpha beta 57 AB, alpha beta 57 CD, beta beta 123 AB, beta beta 123 CD, beta beta 2310 AB, beta beta 2310 CD. So total of 4 into 2, 8 tuples will be there. 8 tuples. So Cartesian, that is Cartesian product. And next we are going to discuss what is natural join. Natural join in the sense, suppose that instead of this I am having, say, C D E F 1 7 A B 5 6 B C 12 3 D E, and suppose that this is A B C D E F. Now we are going to define the natural join operation, that is denoted by this symbol, that is F natural join G. This F and G. Then initially what we are going to do is we are taking the Cartesian product of these two. We are going to take the Cartesian product of these two. Then what is that? Alpha alpha 17 AB, alpha alpha 17 5 6 BC, alpha alpha 17 12 3 D 12 3 DE. And after that alpha beta 5 7, alpha beta 5 7 17 AB, 17 AB, alpha beta 5 7, alpha beta 5 7, alpha beta 5 7 5 6 BC, 5 6 BC. And suppose that we don't have this row for the sake of simplicity, now consider this much: alpha beta 5 7 5 6 BC, alpha beta 5 7 12 3 DE, 12 3 DE, and beta beta 12 3, beta 12 3 17 AB, 17 AB, beta beta 12 3, beta 12 3 5 6 BC, 5 6 BC, beta beta 12 3, beta beta 12 3, 12 3 D, 12 3 DE. That means now you have taken the Cartesian product. This is A, this is B. Here you are having C, here you are having C, so I am going to have F dot C. This is F dot D. B F dot C, F dot D. This is F dot D. Then what is this? G dot C, G dot C, G dot D, and E F, E F. Okay, these are the, when you have taken the cross product of these two, then F natural join G I am going to find out. Here, see, here we are having C and D, here also we are having C and D. Now, here this is the cross product of F and G. Okay, cross product of F and G. We have taken this, and from this you are going to select, that means the operation is you are going to select pi A B, that means you are going to select those, you are going to project A B, then F dot C, F dot D, E F. You are going to select A B, F dot C, F dot D, E F. That means from a table you are going to project this. From which table? From the cross product of F cross G. That means if you are taking the cross product of F and G, this is F and G, and you are going to have a selection operation. That means selecting all, that means here this is F cross G, this is F cross G, and from this F cross G, here the common attributes are C and D, here also C and D. So from this table, F dot C and D dot C should be the same, and F dot D and D dot B should be the same. That means here I am going to have a statement like F dot D equal to G dot D, and F dot C equal to G dot C. That means F dot D equal to G dot D and F dot C equal to G dot C. So see here F dot C and G dot C are same, F dot D and G dot D. So this is qualified. What about this? F dot C, G dot C not the same. This is 1 and 12 not the same. 5 and 1, 5 and 5. See, this is F dot C is equal to G dot C, but F dot D not equal to G dot D. So 5 and 12, 12 and 1, 12 and 5, 12 and 12. See here 12 and 12, and here it is 3 and 3. So this also is qualified. So this also is qualified. That means here the result of F cross G is this much, F cross G. If you are applying this selection statement, you have selected two tuples. That means this tuple and this tuple you have selected. That means two tuples are selected, and from that tuple you are going to select A, B, F dot C, F dot D, E, F. That means from this, if you select A is alpha, alpha, F dot C is what? 1, 7, E, F is AB. Okay. Now what about the other one? Beta, beta, last one, 12, 3, and D, this is DE. So this is DE. So this is the result. And the heads are A, B, C, D, E, F. In simple terms, this is the natural join. Natural join is, here see, in simply speaking, you are going to combine this A, B, C, D and C, D, E, F. For that, what you are going to do is, after doing natural join, here C and D, here also we have C and D. So After doing the natural join operation, AB and EF, here common to both F and G we have C and D. So AB from F, CD common, and from G you have EF. So here CD and CD are common. So for F natural join F natural join G, you have only A, B, C, D, E, F. So a total of 6 attributes will be there. Here we have 4, here we have 4. 4 plus 4, 8. 8 attributes are there in the Cartesian product, but you are excluding. That means here you have CD, here also you have CD. So instead of two CDs, F dot C, F dot C and G dot C, you have to keep one. F dot D and G dot D, among that you are going to keep one. That means here for that, if it is a natural join operation, if F dot C and G dot C are same, and at the same time F dot D and G dot D are same, that means if you have some attributes which are common to both F and G, then F dot C and G dot C should be the same, F dot D and G dot D should be the same. Here see, F dot C and G dot C should be the same, F dot D and G dot D should be the same. That kind of, after taking the join operation, that means F dot C and G dot C same, F dot D equal to G dot D, that kind of tuples are projected, and you are going to keep one among F dot C and G dot C as C, one among F dot D and D dot D as D. So that's why we have A, B, C, D, F. Here you have A, B, C, D, E, F. Okay. Now this is the natural join. Examples for aggregate functions include sum, average, minimum, and maximum. So these are the aggregate operations as far as relational algebra is concerned, and there are a lot of variations for natural join, less than join, greater than join, etc. That will discuss later. Okay, thank you.